Hello everyone. Now today we are going to discuss the problem on surface integral using a projection. Now look at the problem. Evaluate integral over s of dot and ds where f equal to 18zi minus 12j plus 3yk. Okay, 3yk, and s is a part of the surface of the plane 2x plus 3y plus 6z equal to 1 located in the first octant. Okay, now here the surface they given, let's say is x, y and z. When you divide with here 12, now 2 by 6, now 6 units, now y at 4 units, now z at 2 units. Now I think this surface they given, okay, this surface they given like a triangle shape, right? Triangle. Now this surface they given, okay, over that surface we need to integrate it. Over that surface we need to integrate first octant. Now this surface we need to integrate it. Okay, now that surface is not parallel to any of the coordinate surfaces. Now is not lie on any coordinate planes. Now simply we use a projection. Now this situation we going to use a projection case. Okay. Now the given surface pi is 2x plus 3y plus 6z minus 12. Now we need to find out the unit outward one normal. Okay, unit outward one normal. Now normal like this. Go to this direction. Okay, unit outward one normal for this surface. Now for that we need to apply del phi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Dou pi by dou x is with respect to x in derivative is 2 into y plus with respect to y derivative is 3j plus with respect to z derivative is 6. Okay. Now is the unit outward normal for this surface. Okay. Now convert the unit, simply apply the mod. Now unit outward, this is a normal. Now unit outward normal del pi by mod of del pi. Apply it. Now magnitude applied to get for root of 4 square plus 3 square plus 6 square. Now is root of 49 is 7. Okay. Now 2i plus 3j plus 6k by 7 is a unit outward normal for this surface pi. Okay. Now next, now this surface is not lie on any coordinate plane and not parallel to any coordinate plane. Simply use the projection. Okay. Now previous problem, the previous video, I discussed the one problem. The surface belongs to the cube. Now that cube surfaces are parallel. Some are parallel to coordinate plane. Some are lie on coordinate plane. They won't use a projection. But here this surface is not parallel and not lie on. Simply you can use a projection here. Now I consider that R is a projection of S in a XY plane. I use it. I use for XY plane. Okay. You may use in a YZ plane. You may use in a XZ plane. Your wish. Okay. But I use a XY plane projection. Okay. Now the formula integral over s f dot and ds equal to integral over the region f dot n by n dot k dx dy. Now before finding this integration, first I will wait for f dot n and n dot k. Now next you pick up the limits for dx comma dy. Okay, x and y limits, then apply it. Now first f dot n, okay, f dot n, f dot n. Now dot product, apply it. Now here 18zi to y is 36z minus 12 3z minus 36 plus 3y into 6 18y. Okay, now 6 common for each term, 6 by 7 into 6z minus 6y, 6 plus 3y. Okay, now next n dot k. Now n dot k equal to y plus 3j plus 6k by 7 into k dot k. Now only dot product with the k, other are zeros. K dot k is 1, 6 by 7. N dot k is 6 by 7. Mod of that also 6 by 7. Now these two terms are going to apply here. Okay. Now before going to apply here, now we need to know for x comma y variable in projection of xy plane. When you use a projection, now you simply this triangle. Okay. This triangle. Now I will draw this triangle again. Now better to pick up the limits. Okay, now y. Now this is a line we have 2x plus 3y equal to 12. Okay, with z equal to 0 is 12. Now for the covering this region triangle, simply take for vertical strip. For vertical strip, first pick up a y limit. Now y varies with the line x-axis is 0 to this line, where we need to pick up the y value here, 12 minus 2x by 3. Okay, 12 minus 2x by 3, where x moving from here to this point is 0 to 6. Okay, now these limits we are going to apply it, but z value it should be belongs to plane, right? Now where plane we have 2x plus 3y plus 6z equal to 12. From that we need to pick up for z value, but in a rotation we have 6z. Of course we have in a surface also we have 6z. Now I'm going to use that relation. Now 6z equal to 12 minus 2x minus 3y. We have 6z, apply this. Okay, for x comma y limit these two. Now integral over s f dot and ds equal to integral over r f dot n by n dot k dx dy. F dot n already we find it, that is 6 by 7 into 6z minus 6 plus 3y by n dot k 6 by 7 into dx dy. Now x limit 0 to 6, y limit 0 to 12 minus 2x by 3. Now 6 by 7 will cancel. Now what is the 6z? Actually we have varying with only x comma y. Now try to convert the z term also in x comma y. For that reason we use a 6z term here. Now in place of 6z use this. Now is 12 minus 2x minus 3y. Now minus 6 plus 3y dx dy. Now first integrate with respect to y, next x. Okay, now y we will use integrate with respect to y first. Simply y has the variable limit, right? Now simplify this. Here plus 3y minus 3y will cancel. Now remaining 12 minus 6 is 6 minus 2x dx dy. Now first integrate with respect to y. 6 integration 6y minus 2x integration with respect to y is 2xy. Now 0 to 12 minus 2x by 3. Now apply the upper limit minus lower limit. Okay, now here 3 2's are cancelled. Now simplify this. Here 24 minus 4x minus 24x minus into minus plus 4x square by 3. Okay, now 3 1's are 3x. Now integrate with respect to x now. Okay. Now integrate with respect to x. Here 24 integration is 24x minus 12x integration minus 2x square by 2 plus 4 by 3 into x square integration x cube by 3. Now apply the limits, upper limit minus lower limit. Now 24 into 6 minus 6 into x square is x square plus 4 by 3 into x cube by 3. Okay, now your lower limit is 0. For each term having x, apply that 0. Now 24 6 is 144 minus here 6 cube is 216 plus 6 cube into 4 is 864 by 9. Now simplify this, you can get 20. Okay, now this is a way we use a projection to evaluate the surface integral. Thank you.